Okay, we will complete. We said that the first one, the thermochemical equation for burning or combustion of ethanol, it produces 2 molecules of carbon dioxide gas and 3 moles of water. Okay, the molar mass of ethanol or ethyl alcohol, okay, this name, the other name for ethanol, we called it ethyl alcohol. Okay, we will perform the molar mass at first. Okay, we have carbon here, we have 12 times 2 plus 5 times 1 hydrogen, the atomic mass of hydrogen, plus 16 and plus 1, the last one. Okay, so we have the molar mass of ethanol 45 gram per mole. Number of moles of ethanol, we have the mass over molar mass. Mass or divided by molar mass produce the number of moles. So we have here number of moles. We have here a wrong for the rule. We didn't have negative sign. The rule of any change of heat make a quantity of heat divided the number of moles. We haven't here any negative sign. Okay, this is a wrong for different books. Okay, so we will calculate the quantity of heat Q at standard conditions. So we called it QP. QP equal delta heat of combustion time number of moles. So we have here exothermic reaction. So the Q will with a negative sign, not positive sign, like this problem. Okay, most of problems we have here are wrong due to the negative sign that some books added negative to the rule. Okay, we have another problem here. We wanted to calculate the standard heat of combustion for propane. Okay, we have heat content for combustion of 8 gram of propane. Okay, if we have a different masses for any substance, so we called it a combustion. We called it just combustion. But if we produce it for 1 mole of this substance, so we will take it in the standard heat of it. Okay, if we make a burning for 8 gram of propane in excess amount of oxygen, okay, we have here propane 8 gram, it will produce this amount or quantity of heat. We will perform the molar mass of propane. 3 carbon atoms times 12 plus 1 times 8 produce 44 gram per mole. Okay, we want here the amount of heat or standard heat of combustion for 1 mole of propane. Okay, we will divide. We have the rule here not written. We have the rule here, Q equal delta Q equal delta H time number of moles. So we have delta H here, Q over number of moles. Q quantity of heat here 45. We will make cross multiplication. 45 times negative 422.49 kilojoule divided by the mass here, cross multiplication, it will produce this amount of heat of combustion. We have a negative 2323.7 kilojoule per mole. Okay, this is very easy and very simple for the standard heat of combustion. We have the second type of chemical exchange. We have the heat of formation, standard heat of formation. The same as we said, we have heat of formation. Any pure substance that make a reaction will produce a compound. We called it heat of formation. and make increase in temperature, we called it heat of formation. But if we make it at standard conditions, so we called it standard heat of formation. Okay, يبقى under standard conditions we called it standard heat of formation. Okay, quantity, it means that quantity of heat released or absorbed when 1 mole of compound formed due to or formed from its simplest element or constituent element, where these elements are in standard conditions. As we said before, standard conditions, it means that we take 1 mole of the substance. Okay, we have a standard state for some elements. We have carbon. It take 2 states. We have graphite and diamond. The standard state of carbon, we called it graphite. Why? As it is the most stable state of carbon at standard conditions. Okay, we have another application in our life. We have standard heat of formation of glucose. Standard heat of formation of glucose. Okay, if we have 6 carbon atoms and 6 hydrogen molecule, okay, and 3 oxygen molecules, so it will produce the 1 mole of carbon at standard conditions. Okay, here at the end of it means I need only 1 mole produced from these atoms. Okay, يبقى standard heat of formation of glucose. If we wanted to produce 1 mole of glucose, it will make energy or release energy very high due to formation of bond, so the reaction is exothermic. Okay, and heat of formation will be with a negative sign. Okay, we have another example, or we have a question here. What's meant by standard heat of formation of glucose is this number. It means that the quantity of heat released or absorbed, or we have here heat released, as it is exothermic reaction. When 1 mole of glucose is formed from its constituent or its elements at standard conditions equal, we have the number here 1260 kilojoule. Okay, يبقى we have heat of formation of any element. We have here of heat of formation, heat of combustion, heat of dilution, as we taken before, heat of solution. All of them for any element will be 0 in the standard conditions. Okay, okay, we have to know, or we calculate, the change in heat content or enthalpy delta H of reaction in the terms of standard heat of formation. Okay, if we want to calculate it, we have that change in heat content. How it will produce? We have heat content of products minus heat content of reactant. Okay, as we said before, heat of formation of compound, heat of formation of compound equal its heat content. So delta H equals sum of heat formation of products minus sum of heat formation of reactants. We will say a note here, heat of formation of reactant, it will be all times take a negative sign. Okay, we will take an example for this. If we have the reaction of element with another element that produce two compounds. Okay, so delta heat